Hello friends, welcome back for another deep learning project, the subscription Seer. The subscription Seer is a deep learning model which classifies whether a bank customer will have a subscription to bank term deposit or not. So what are the steps that I followed to build this model? Let's see and let's discuss. At first, I have imported libraries like Tensorflow, Keras, and from Keras utils feature space, pandas, and numpy. Tensorflow and Keras are for building the model, and feature space is to pre-process the dataset, pandas for data manipulation, and numpy, as usual, it is for numerical calculations. After that, I have imported warnings library. Warnings library is used to filter out the casual warnings given in the notebook. A filter warnings method in warnings library is used to filter out all the warnings. After that, I have loaded the bank.csv file using read CSV method of pandas and assigned that to a variable df, and I call it data from. So the first step of building a machine learning or deep learning model is to check what are the properties of the data frame. So let's get into the first step of building a machine learning or deep learning project. Using head method of pandas and applying it to the data frame, we will get the first 5 rows of the data frame. So these are the rows we got. Next property is shape. So we have 4119 samples and 22 features, and let's check what are the columns of it. So we have unnamed 0, that is the index column, and we will remove it. And we have age column, that is age of the client. Then job column, what is the type of job the client is doing. And then marital column says about marital status. Education, it is the education level of the client. Default, whether the client has credit in default or not. Housing, whether the client has housing loan or not. Loan, whether the client has personal loan or not. Contact, the communication type of client with bank. Month, last contact month of year with the client. Day of week, last contact day of the week with the client. Duration, last contact duration in seconds. Campaign, number of contacts performed during this campaign and for this client. PDays, number of days that passed by after the client was last contacted from a previous campaign. previous column, number of contacts performed before this campaign and for this client. P outcome, outcome of the previous marketing campaign. emp.var.rate, that is employment variation rate. cons.price.idx, that is consumer price index. conf.idx, that is consumer confidence index. And Euribor 3-month, that is Euribor 3-month rate. nr.employed, that is number of employees. And at last we have column Y. So these are the columns whether we have the client has subscribed a term deposit among these not. That is how the columns will be removed. Next property. So we have 5 columns of float 64, 6 columns of int 64 and 11 columns of object type. So these are the columns and count of non-null values and their d types. Next property, correlation. So correlation between columns. Then description or quantiles. In first row we have the counts of numerical columns, then means of numerical columns, standard deviation of numerical columns, minimum values of numerical columns, 25 percentile, 50 percentile, 75 percentile of numerical columns, and finally we have maximum value of numerical columns. Then I am selecting the categorical columns and saving it in the variable categorical calls. After that, using a for loop, I am finding out the unique values of the column and printing those. So in job we have blue collar, service, admin, entrepreneur, self-employed, technician, management, student, retired, housemaid, unemployed and unknown. These are the unique values of job. Marital have married, single, divorced and unknown values. Education have basic.9y, high school, university degree, professional course, basics 6y, basics 4y, unknown and illiterate. Default have no, unknown and yes. Housing has yes, no, unknown. Loan has no, unknown, yes. Contact has cellular and telephone. Month has May, June, November, September, July, August, March, October, April, December. Day of week has Friday, Wed, Month, Thursday, Tuesday. And P outcome has non-existent, failure and success, and the target Y has no and yes. Next I am selecting the numerical columns and saving in numerical calls variable. Then using the for loop I am printing the unique values of numerical columns. So these are the unique values of numerical columns, and some numerical columns are categorical numerical columns, that is integer categorical columns. So we have to go through it carefully, which are integer categorical and which are not integer categorical, and which are float type. We should carefully observe the numerical data. Then next step is data cleaning. So in data cleaning I am doing 3 to 4 steps. Those steps are dropping the columns, removing the unknown values, and creating a new feature. So using the drop method of pandas, I am dropping the columns like duration and unnormed 0 column from the data frame and saving the modified data frame in the same data frame using the argument in place equal to true. After that, I am removing unknown values. We have unknown values in the columns like job, marital, education, default, housing and loan. So I am selecting only these columns and using a for loop I am iterating over the columns and finding out the unique values of the column and saving in the unique values variable. Then I am removing the unknown value from the list or unique values, and after that I am using apply method of pandas, applying it to the data frame. Inside that, a lambda function which randomly chooses the unique value and replaces with the value which is unknown in these columns. So to choose the random value, I have used the choice method of random module in NumPy. Then creating a new feature previously contacted using the PDS column of the data frame and applying the map method to it. And inside the math method, I am using a lambda function where if the value in PDS is equal to 999, then I am assigning 0 to the previously contacted, and if not, I am assigning 1 to it. After doing all the cleaning steps, we have 4119 samples and 21 features. Let's have first 5 rows. So these are the rows we have with us after cleaning. I am saving it with the name cleanedbank.csv using the toCSV method and applying it to the data frame. Yes, it is successful. After that, I am splitting the data frame into training and validation parts. 20% of the data are selected randomly and saved in the validation underscore df, and 80% of the data is saved in the train df. So using the sample method, I am selecting 20% and saving in validation df and dropping the indexes of the validation df and saving it in the train df. So let's see the shape of these two splitted data frames. So we have 3295 samples in train df and 824 samples in validation df. After that, I am generating Tensorflow datasets from data frames. So before that, I am creating a string lookup layer to encode the levels. So we have two categorical levels, no and yes. So in string lookup, we have to provide the vocabulary. So in vocabulary, it takes a list of categorical values or the unique elements present in the target column. In the order we assign the values to the vocabulary argument, same order will be used to do the string lookup. So you should carefully order the target column elements, and the second argument is num of indices equal to 0. So it is number of out of vocabulary indices. It means that if any unknown target value or any unknown value is found during inference, then we have to assign the number of spaces for that. So I am not assigning any space, and I am considering only two values will be found, that is no and yes. Other than that we won't find, that's why I am choosing it 0. If you find any other values, then it should return an error. So I am storing this layer in a variable label lookup, and it is a pre-processing layer. After that I am creating a function encode level which takes two parameters x, y, and passing the y to the level lookup pre-processing layer and saving it in encoded y variable and returning x and encoded y. Then again I am creating another function that is to convert data frame to dataset, and the name of the function is df to ds, passing a parameter df. Inside the function I am copying the passed data frame and saving in the data frame or df variable. Then using the pop method of the pandas, I am selecting the output column and saving in levels variable. Then using the from tensor slices method of tf.data.dataset API, I am generating the dataset, and from tensor slices I am creating a tuple, and inside the tuple I am passing two values. The first value is the dictionary of the data frame, and the second value is labels, and then I am saving it to the ds variable. It stands for dataset. After that I am mapping the dataset with encode level. So to encode the levels, and using num parallel calls equal to tf.data.autotune to dynamically assign the number of CPUs that the system has for pre-processing, and then shuffling the dataset with buffer size equal to length of the data frame and returning the dataset. After that I am applying data frame to dataset function to both train data frame and validation data frame, and saving them in train dataset and validation dataset respectively. To have preview of first value in the train dataset, I am using the take method and passing 1 to get the first sample, and printing x and y, x for the dictionary of input features and y for the target. So you can see here we have age equal to 37, job equal to technician. Similarly we have many values, and this is the dictionary. These all are inside the dictionary, and in target we have value 0, it is of type int 64. After creating dataset, time to pre-process the dataset. So to pre-process, we have to create a feature space. Feature space is like a column transformer in scikit-learn library. I hope you are aware about column transformer in scikit-learn. If not, it's not so difficult, and I will explain you about each steps I have done here. So at first I am removing the levels in the training dataset using the map method applied to the training dataset, and inside the map I am applying a lambda function which takes two variables x and underscore, and it returns only x. So we are removing levels and saving it in the variable train ds with no levels. Then configuring the feature space. Configuring means which feature is treated with which transformer. So that's what we do in the configuration. So let's see, I have created a variable feature underscore space for feature space utility, and inside that I am passing an argument features with a dictionary of features and their respective transform function. So all the keys are the names of the column, and all the values are the functions which is applied to transform the columns. Then I am crossing some features like age and job and setting the dimension of it to 8. Then again I am crossing housing and loan columns and setting the dimension to 6, and also I am crossing p outcome and previously contacted features and setting their dimension to 2. And at last finally I am concatenating all the pre-processed features using the output mode equal to concat. After configuration of feature space, I am batching the training dataset and validation dataset, and with size of 32 elements in each batch, and saving them in their original variables. After that I am adapting the feature space with the train ds which doesn't have any levels. So it is taking some time to adapt the feature space. Yeah, it is adapted and a warning is thrown. So let's move forward. After that I am pre-processing the data. So in pre-processing I am applying map method to train ds, and inside the map method I have lambda function. Two parameters x and y are given to the lambda function, and I am passing x to the feature space, and the lambda method returns us a tuple with two values. The first value is feature space of x and the second value is y. So here we are pre-processing the x value and saving in the tuple and returning it. Then I have passed another argument number of parallel calls equal to tf.data.autotune to set the number of CPUs dynamically. Then I am prefetching. Prefetching is to load the data before model starts executing. So I am doing it to both datasets, train ds and valley ds, and saving them in preprocessed train ds and preprocessed valley ds respectively. After that, it is the step to build the model. So we are building two models, one is for training, another is for doing the inference. So feature space provides many features like getting the raw inputs or getting the encoded features. So using the method get inputs applied to the feature space variable, I am finding the raw inputs, so it is saved in dict inputs. Then applying get encoded features to feature space, we are getting encoded features, so it is saved in the variable encoded features. Then I am creating the layers in the model. At first I am creating a dense layer with 64 units of neuron and applying ReLU function to it and passing the encoded features to the layer and saving the output in the X. Then I am creating a dropout layer and passing the output X to it. It is dropping 0.5 out of all and saving the output in X. And finally I am creating another dense layer with one neuron and having sigmoid activation function and passing the output X of dropout layer and saving this in the variable output. These are the layers we have in our model. Then using the functional API, the method model of Keras is used to build the model, and here we are passing two arguments, that is inputs is encoded features and outputs is output of the final dense layer, then saving it in the variable model. After that I am compiling the model using the optimizer Adam and the loss function binary cross entropy, and the matrix is accuracy. Then training the model using the fit method of Keras. So I am giving preprocessed train dataset to train the model and providing validation data to it and setting the epochs to 20 and variables to 2. So let's run it. So it is executing, or the model is training. 13 epochs completed, 18 epochs completed, a final epoch completed. So we got 91.14% of validation accuracy. Wow, superb. So as the user provides us raw inputs, for the purpose of that we have to build an inference model. So in inference model we have to give raw inputs, that's why I am using inputs equal to dict inputs and outputs equal to output in the model method of Keras library and saving it in the variable inference model. And then saving the inference model with the file name inference model dot Keras. After that, as I said, we are going with row inputs. That's why I'm creating a sample with row inputs and converting it to tensor and saving the dictionary to input dict, and using inference model dot predict we are predicting the output. So if age equal to 30, job equal to blue collar, marital is married, education is basic 9, by default is no, housing is yes, loan is no, contact is cellular, month is May, day of week is Friday, campaign is 2, P days is 999, previous is 0, P outcome is non-existent, employment variation rate is minus 1.8, consumer price index is 92.893, consumer confidence index is 46 minus 46.2, Euribor 3-month rate is 1.313, and number of employees is 5199.1, and at last previously contacted is 0. Let's see what is the percentage of subscription to a term deposit if a client possesses these features. So the model predicting that 8.39% of probability of subscribing the term deposit. So with this we have completed the first part of our this subscription Seer model. Thank you. Welcome to second part of the subscription Seer model. So here I am doing the user interface so that users can check how the model works and what the model does. So let's get into what I have done. At first I am importing the libraries like Streamlit, Tensorflow, Keras, Pandas and NumPy. Streamlit is to create user interface, Tensorflow and Keras for building the model and loading the model, Pandas and NumPy for data manipulation and numerical calculation respectively. I am loading the model using load model method of models module in Keras library. So the name of the file is inference model.keras and I am saving it in the variable model. Then I am reading the cleaned bank.csv file with the read csv method of pandas and saving it in df. Then creating the page. So inside the page I am creating a container for title of the project. Inside the container I am creating two columns with varying width and setting the vertical alignment equal to top. Then inside the image column I am giving an image with width of 100, and inside the title column I am giving the title the subscription Seer with the color rainbow. So it has 7 colors. After that I am creating the about project section with another container. Inside the container I am creating an expander which is defaultly expanded, and inside the expander I have written some text. So let's read that in the user interface, not here. After that I am creating a container for the output and setting it as empty. Then I am creating a container for input section. As in inputs we have 20 features, so I am creating 20 columns and 4 columns in each row. So we have age call, job call, marital call, education call, default call, housing call, loan call, contact call, month call, day of week call, campaign call, P days call, previous call, P outcome call, employment variation rate call, consumer price index call, consumer confidence index call, Euribor 3M call, number of employed call, previously contacted call. These are the columns name that I have created. Under the age column, I am creating a text input where the label is age and placeholder is minimum value to maximum value of the age. Then if age is entered, I am converting the data type to integer 64. And then under the job column, I am creating a select box and the label is job. The unique values of the job column are its option. Under the marital column, I am creating a select box with the label marital status, and unique values of marital column are its options. Under the education call, I am using a select box and giving the label education, and unique values of education column are its option. Under the default call, I am using select box, giving the label as default, and unique values of that columns are given as options. And then similarly to housing column, loan column, contact column, month column, and day of week column, I am giving their unique values as their options and the label as per their column names. After that, for campaign column, I am using text input and giving the minimum value to maximum value as its placeholder, and then converting the campaign value to integer of. Then for pdays column, I am using a text input and giving the label as past days and having placeholder as the minimum value to maximum value of pdays column, and if it is entered, then I am converting it to int64 data type. Similarly, I am applying it for previous call. Then in p outcome column, I am using a select box and giving a label p outcome, and the unique values of p outcome column are the elements given as option. Then in employment variation rate column, I am using text input. So minimum to maximum values are given as placeholder. Employment variation rate is the level of it, and if it is entered, I am converting it to float 64. Then similarly to consumer price index, consumer confidence index, Euribor 3-month column, number of employees, I am applying float 64 if they are entered. Then to the last column, previously contacted, I am using a select box and giving label as previously contacted, and options are the unique values of that column. Then if the text inputs are given by the user, I am creating a sample with a dictionary. So inside the dictionary, the keys are the column names and values are the value entered by the user or selected by the user. Then converting it to tensor using the values and the convert to tensor method and saving it in the variable input dict, then providing input dict to the method predict applied to the model and saving the output in predictions. Then I am creating a container to the empty variable that we created and saved as output, and in that container I am having a write method, and the write method shows this as its output. Then I am creating a container for sharing the links like YouTube, Hugging Face, Medi, my personal page, repository and LinkedIn. So I am creating 5 columns with varying width sizes and providing small gaps between each column and having these names to the columns. Then under those columns I am providing a link button to each column, and in each link button I am providing a label. Those labels are video, HF space, Medi, repo or connect. Then I am passing another argument icon to each link button, and then I am providing URL as another argument, and finally I am providing help section to each link button. With this we have completed the second part of the subscription Seer model. So let's run this. To run this, open the terminal. So we have to change the directory. So we are in subscription C directory. So to change the directory, enter cd and the directory name. In my case it is the subscription Seer. I have successfully changed the directory. And to run the streamlit file, write streamlit run and file name, that is app.py in my case. So press enter. It is taking some time to gather all the data. Yeah, it came. So here we go. It is the title, the subscription Seer, with all the colors present in a rainbow. Then an image. What is this? The subscription Seer is a supervised deep learning model that uses the features to predict whether the client subscribed or not to the bank term deposit. An artificial neural net is used to build this model. Okay, so these are the inputs we have to provide to get the output. Inside this we have some placeholder values. So placeholder values to be carefully seen and the values to be entered as per the given placeholder condition. So here as is to be entered between 18 to 88. So I am entering, let's say it is 35. Let's say it is 35. Then I am saving the job as blue collar. Let the selected values be the same. Let's enter first the entering values. So campaign is between 1 to 35. Let's provide it 2, and the number of passed days should be between 0 to 999. So let it be 300, and in previous input we have to enter between 0 to 6, so let it be 3. Then employment variation rate should be between -3.4 to 1.4, let it be -2. Then consumer price index should be between 92.2012 to 94.764, let's enter it to 93 as its value. Then consumer confidence index should be between -50.8 to -26.9, so let's enter its value to -35. And Euribor 3-month rate should be between 0.635 to 5.045, so let it be 3. And the last number of employees is 4963.6 to 5228.1, so let's enter it to 5000. So press enter to get the output. Yes, here we got the term deposit subscription probability is 25.98% if these are the features posing by the client. So let's change the blue color to services, so it becomes 28.63%, and if he is an admin it is 33.12%, and let's change it to single, it becoming 32.63%, and if it is divorced it is 28.68%. let's keep it married, so we are getting 33.12%. and let's change it to university degree, so we are getting 41.97% of subscription probability. Then let's change the default to yes, so the subscription is changing to 36.34%, let's change it to no, as banks want a client to take the subscriptions of their banks, that's why we will try to increase the percentage of having a term deposit subscription. So let's change this housing to no, it increased to 45.60%. let's change the no loan to yes, it is decreasing the subscription probability, so let's keep it no. And let's change the contact to telephone, it is also decreasing our subscription rate, let's keep it cellular. Then in month let's select June, it is increasing to 68.49%, let's change it to November, it is decreasing, not required, let's change it to September, it is also not greater than to June, let's change to July, it is 50, okay, but not greater than to June, let's go to March, better than July but not greater than June, let's go to March, and we are getting 73, greater than June, let's try 3 more month values, if it is in October, no, it is decreasing, so March value is higher than all, if it is April, no, if it is December, no, so we have to keep it March. So let's keep it much. So we are getting 73.38% of subscription probability by a client who has these features. After that, let's change the day of week. So in Friday case we have 73.38%. If it is Wednesday, it is 72. If it is Monday, 73.95. Oh wow. If it is Thursday, 73.35. Okay. If it is Tuesday, 74. Wow. Let's keep it Tuesday. So let's keep the entered values as same. So if the P outcome is non-existent, then the output is 74.05%. If it is failure, then it becoming 59.16. So if it is successful, then it is 72.96. So keep it non-existent so that we will get highest. After that, we have previously contacted value. Let's change it to 1. We are getting 77.67%. So with this, I'm completing this project. Thank you for patiently listening to me and my project. Thank you very much.